Welcome to ClickMyProject.com. Now we are going to discuss about the project Edge Detail Enhancement Algorithm for High Dynamic Range Images. Now we are going to discuss about the abstract of the process. Existing image enhancement method have problems of the slow data transmission and poor conversion effect, resulting in the low image resolution and recognition rate in the recognition efficiency. To resolve these problems and improve the recognition accuracies and the effectiveness of the process and then the effectiveness of the features, this study proposes an edge detail enhancement for the high dynamic range image ranges for enhancing the quality of the image. Finally, the experimental result shows the proposed high dynamic range image edge detail enhancement algorithm maintains the image recognition rate of more than 80% during the particle applications, and then the recognition time will be the very low within the 1 minute, which enhance the image effects, improve the recognition accuracy and then the efficiency of the process. Hence it will improve the quality of the image by means of the edge detail enhancement. By this method we can improve the quality as well as improve the recognition rate by improving the feature quality. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The modules consist of this project as input image, pre-processing, filtering, fusion, enhancement and finally performance estimations. At first the input image will be taken from the dataset. The dataset consists of the low resolution images. After getting the low resolution image from the dataset, we just move on to the second step of the process, that is the pre-processing. In this pre-processing we are going to do the image resize. Why we are doing the image resize? In the sense, for example, some image having the higher dimension, some image having the lower dimension in the dataset. So due to this reason we have to resize the image into an aspect ratios. After the pre-processing we just move on to the third stage of the project, that is the filtering. In this filtering, first the image is split into two types, that is the high pass image then the low pass image. After converting the single image into one high pass image and then the low pass image, some of the details will be present in the high pass image, some of the details will be present in the low pass image. Now the high pass image will be get into the grayscale conversion. Then the low pass image will be get into the CLA-HE method, that is the kind of the histogram equalization method. After getting these two results, we just fuse the two result by using the BM3D method. So the next module is the fusion model. In this module we are going to use the BM3D model for fusing the gray image and then CLA-HE image. After the fusion of these two image, some of the details present in the grayscale image, after the some of the details present in the CLA-HE image will be combined together to generate the new image. After the fusion we just move on to the next stage of the process, that is the enhancement. If the quality of the edge region is somewhat degraded, means it will be enhanced by means of the Weiner filter. After the enhancing the filter by using the Weiner filter, we just do the performance estimation. So in this performance estimation we are going to use the PSNR and MSE to estimate whether the process is working good or not. So PSNR in the sense peak signal to noise ratio and MSE in the sense mean square error. Now we are going to discuss about the initial running procedure of the process. At first open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_100.m. Now the dataset will be open. In that dataset you can select any image from the dataset. After the selection of the image from the dataset, the corresponding process will be done automatically. Once the process is done, I will explain the results one by one. Now the process was done. Figure 1. This is the figure 1 which I have taken as an input from the dataset, which is in the title of input image. After getting the input image, we are going to do the image resize. So figure 2 represents the pre-processed image, that is the resized image. The resize will be done in the size of 256 x 256. which means the number of row will be the 256, number of column will be the 256. After getting to the resize, we just move on to the third stage of the process, that is the grayscale conversion. This is a kind of the filtering. So using this filtering, we are going to convert the image into a grayscale format. Whether it is looks like a grayscale images, maybe the channels will be the RGB. So we have to convert that RGB channels into a grayscale form in this figure 3. After the figure 3, we just apply the FFT as a low pass image. So the FFT low pass image will be looking like this. The backgrounds will be suppressed, then the foregrounds only will be the enhanced region. After applying the low pass filtering, we have to apply the wavelets. So wavelet image 1 and 2 represented here. After applying the wavelets, this wavelets will be converted into 4 kinds of categories, that is the low frequency, low high frequency, high low frequency, then high frequency. Like this we have converting the wavelets into 4 kind of frequencies. Then the fused image will be shown like this. In this fused image, the low pass image and then the high pass image both will be fused together to generate the new image. You can see the difference between the input image and then the fused image. Some of the results will be edges will be the enhanced. After that, the final resultant image will be looking like this. It will enhanced by using the Weiner filter. After applying the Weiner filter, we just move to the performance estimation. In this performance estimation, we have performance parameters like PSNR, MSE, ME and entropy. So PSNR in the sense, already you know about the PSNR, peak signal to noise ratio. Then MSE in the sense, mean signal error, mean square error. Then MI in the sense, mutual information or mutual index. Then entropy. Thanks for watching this video.